Alright, pre-calculus, here we are. This is section 2.1 over quadratics, okay? The entire chapter 2 is over what we call polynomials, okay? And polynomials are fairly easy to work with, okay? Polynomials are functions, okay? They're continuous functions. The domain is all numbers, negative infinity to infinity, so that makes it easy. And they kind of look like this. They got a sub 1 x to the n plus a sub 2 x to the n minus 1 plus a sub 3 x to the n minus 2. And this goes on forever. Now you got to remember these a's right here, the numbers in front of the variables, are called coefficients. Coefficients, okay? And then the n right here is known as the degree. The degree is the largest exponent you see. So let me give you a couple quick examples. So we got 3x to the fifth minus 4x cubed plus 2x minus 7. Okay, so the 3, the negative 4, the 2, and the negative 7 are what we call coefficients. And the largest exponent right here is a 5. So we say this is a fifth degree polynomial. It has the degree of 5. It's the largest exponent you see. It's that easy. And the number in front of that largest degree is what we call the leading coefficient. And note that the leading coefficient does not always have to go first. For example, I can throw things out of order here. 8 minus 8x to the third plus 2x to the eighth minus 4x to the seventh, for example. Okay, a little bit out of order here, but as you look at this, the largest exponent is 8, so this would be an 8th degree polynomial, and the 2 that came with that 8 is known as the leading coefficient. So even though it didn't go first, it doesn't matter. The largest exponent always tells you who the leading coefficient is, and that largest exponent is known as the degree of the function. So those are polynomials. Well, this first section, 2.1, is only over quadratic polynomials. In quadratic polynomials are special polynomials that are the second degree. Okay, so none of these examples right here are quadratics. Quadratics have to have a second degree, which means the highest exponent is a 2. So one like this, 3x squared minus 4x plus 5. That would be considered a quadratic because the highest exponent is a 2. And the leading coefficient would, of course, be the 3. Now, with all polynomials have zeros, okay? And zeros are really, really, really important. In fact, the main focus of much of the first part of this entire chapter are going to be on zeros. Zeros are also known as solutions. So the solution of a polynomial is known as the zero, and graphically they are where you cross the x-intercept, or where you cross the x-axis, which is known as an x-intercept. Okay, so if we look at this graphically, a polynomial could look like this. There's some twists and some turns. Okay, there's a polynomial right here. And the zeros are where it crosses the x-axis. So this particular one would have 1, 2, 3, 4 zeros. And our goal is to find those zeros. So simply put, our main goal of a lot of this chapter is to find the zeros, which are also known as solutions or x-intercepts. Okay. Now we're dealing with most specific ones, quadratics. Okay. So let's talk about the general form of a quadratic for this general quadratic. This is for this first particular section, 2.1. A general quadratic is a function that looks like this: ax squared plus bx plus c. Notice it has to have this too. So a cannot be 0. If a was 0, it would wipe all this out. So you don't have to have a b, you don't have to have a c, but you have to have an a in front of the x squared, because you're not a quadratic if you don't have the x squared. So this is our general form of a quadratic, and what we want to be able to do is to find two things. Number one, we want to be able to find the vertex. And let's talk about that for a second. When you're a quadratic, you have this shape called a parabola. Hopefully you've heard that term before. And the shape of a parabola could open up like this, or the shape of a parabola can open down like this. Okay? So the point of a parabola is both ends are going up or both ends are going down. But regardless, this point right here where the parabola makes its turn is known as the vertex. So this is going down, 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 and then it turns and goes up, 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 up. So where you make that turn is known as the vertex. Or this one's going up, 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 up. At this point, it makes a turn, and now it's going down, 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 down. That point is known as a vertex. It's a pretty important point of any parabola. Obviously, this vertex is only on quadratics. So the formula to find this vertex is really easy. It's x equals negative b over 2a. Now that will find the x coordinate of that vertex. Now, if you notice that looking at the graph, the vertex is a point. It's x comma y. So to find the x value, it's negative b. Again, that comes from right here in the general form. So there's the b. So you need negative b. And you need 2 times a. So c has nothing to do with the vertex. And then to find the y coordinate, whatever you get for this, like let's say you get 5, then you would plug 5 in for x, and whatever you get for f of x becomes the y. So let's just show a quick example of how to find the vertex. But before we do that, I want to talk about the second most important thing when you're dealing with these quadratics in general form, is to find the zeros. Okay, to find the zeros. Now let's quickly talk about the zeros. When you're dealing with a quadratic, it could potentially look like this. And how many zeros are there? Well, there's 1, 2 zeros. So you could have 2 zeros. You will never ever have more than 2 zeros in a quadratic. You could actually only have 1 if your quadratic just barely touches. So the vertex is actually right on the axis, so you barely scrape it, like you just scrape the x-axis, which is where zeros occur, and you have what we call 1 0. So there's only 1 0 right there. Now that's kind of important to understand. We'll talk about that shortly, but that 0 is like repeated. So because remember, quadratics have to have this whole idea of an x squared, so maybe it's the same thing but it's repeated. So we'll talk more about that in a second, but there's only 1 0. And another option is the quadratic could open like this, where it's like too high and there are no zeros. It never ever crosses the x-axis, so there's no zeros. So when we're talking about zeros, we could have 2, 1, or none. And we're going to show you exactly how to find zeros. Now, to find zeros, you need something what we call the quadratic formula. The quadratic formula is up on the wall in the front of the room, so you'll never forget it. It is negative b plus or minus the square root of b squared minus 4ac all divided by 2 times a. Now, because of the plus or minus, you could potentially come up with 2 zeros because you're adding, and then you're going to do the same thing with subtraction. If you get a 0 inside of here, you're going to have 1 0, because plus or minus 0, it doesn't matter. Like 2 plus 0 is 0, and 2 minus 0, 2 plus 0 is 2, and 2 minus 0 is also 2. So if you have a 0 inside of here, you're going to end up with 1 solution. If you get a negative inside of the square root, we've talked about that a lot of times, you cannot have negatives in square roots, so you would say there's no zeros. So that's when no zeros occurs. So if this inside number right here, b squared minus 4 times a times c, is positive, you're going to have 2 zeros. If it's negative, you're going to have no zeros. And if it is 0, you'll have 1 0. So that may occur as well. So the two things we have to be able to do are find the vertex and find the zeros. So let's look at a couple examples here, and let's actually go ahead and do that. So the first example I want to take a look at is x squared minus 2x minus 15. So the function is x squared minus 2x minus 15. And let's first go ahead and identify a. A is the number in front of the x squared, which would be a 1. B is negative 2. That's the number in the middle in front of x. And c is negative 15. Now be careful, because if there were no x's, then there would just have a b value of 0. Or if there was no c value back here, it would be 0. But you have to have an a value. So let's go ahead and find the vertex first. It's really, really easy to do. All you got to do is find the x coordinate. Remember, vertex is a point, x comma y. So to find the x coordinate, all you got to do is use this formula right here, negative b over 2a. So that means the opposite of b. So negative, negative 2 would actually make a positive 2 on top. 2 times a, 2 times 1 is 2, so my vertex is at 1. That's a nice, easy point. Now to find the y, I have to plug 1 back into this equation. Feel free to do it by hand, or you could use your calculator, okay? So I'm going to pull up the calculator here, and this may take a second, but I'm going to show you a hint real quick of how to do this on the calculator really easily. It's not too hard to do when you have a simple number like 1, but if you would have a trickier number, for example, like if you had a fraction or a negative, it can be a little tricky. So we're going to do 1 store, it's a little STO button, as x. So we're going to tell the calculator x is 1, and then we're actually going to just type in here x squared minus 2x, and the x button's right underneath mode here, minus 15. And that's going to tell us that the coordinate is at negative 16. So that means the y-coordinate is at negative 16. So that's your vertex. So it's at 1, negative 16. Now we want to find the zeros. Okay, now there are two ways to find zeros. There really are. The first way is to factor. So let me show you the first option to find zeros. It's to factor. So if I'm going to factor this, I'm thinking x squared is x times x. 15, it would be a 3 times a 5. And the 5 would need to be negative, and the 3 would need to be positive in order to make that negative 2 in the middle. And then the 0 rule says one of these two things must be 0. So x plus 3 could be 0, giving me a solution of negative 3. And remember, solution means 0. Or x minus 5 could be 0, giving me a solution of 5. And remember, solution means a 0. So these are my two zeros right there. So if you don't like factoring, or sometimes it can't be factored, like it's literally impossible, you have to go ahead and use the quadratic formula. So let's show how easy that can be. Okay, the quadratic formula is the opposite of b, so that would be positive 2, because b is already negative, so negative 2 would be positive 2. Plus or minus the square root of b squared is 4. That's b squared, negative 2 squared is 4. Don't ever make this negative, because remember, anything squared is always positive. Minus 4 times a is 1 times c is negative 15. Okay? All divided by 2 times a, which is 2. Okay? 2 times 1 is 2. So let's see here. Sometimes kids get tricked. Remember, on the inside you have to multiply before you can do any type of subtraction. If you use your calculator, it'll give it to you right away, and it'll do the order of operations for you. 4 minus 4 times 1 times negative 15. Please just double check that you typed that in right. 4 minus 4 times 1 times negative 15. And don't ever do that subtraction first. Remember, you got to multiply first before you do the 4 minus. And you get 64. So inside of this square root here is a 64 all divided by 2. Now the great thing is the square root of 64 is a perfect 8. So I get 2 plus or minus 8 all divided by 2. So let's go through here. 2 plus 8 is 10. 10 divided by 2 is 5. So there's 1, 0. And hey, that's the same 0 we got right here. 2 minus 8 is negative 6. Negative 6 divided by 2 is negative 3. So that would be the other 0. So we have two zeros. 5 and negative 3 are my two zeros for this quadratic. So that one worked out pretty nice. All right, let's move over here and we'll take a look at a second problem. Okay. A second problem right here. Let's go ahead with, let's do a fun one here. Let's see here. The function is, I got it written down here, 2x squared minus 12x plus 22. Okay, and let's see here. I'm going to go ahead and the first thing I'm going to do is find the vertex. Remember, the vertex is a point. Okay, and the first point is x, and to find that value of x, I use a simple formula, negative b over 2a. So negative b is the opposite of negative 12, because b is negative 12, so negative 12 would be positive 12. Divided by twice a, so a is 2, so 2 times 2 would be a 4. 12 divided by 4 is 3. So that means the x-coordinate is at 3. Now to find that y-coordinate, remember, use the calculator. Let's go ahead and tell the calculator 3 store x. So we're going to tell the calculator that x is 3. And then we're going to do 2x. It's just so much easier when you tell the calculator to do it for you, especially when you store. You don't have to worry about typing in parentheses or anything confusing. Just got to make sure you type it in right here. And we get 4. That's a nice value there. So my vertex is at 3, 4. And now I got to find the zeros. Now, first option is to factor. And if I'm looking at this, I could probably factor out a 2. So if I take out a 2, I get x squared minus 6x plus 11. But then I don't think I could factor this, because if I make that x, and then the only way to ever get an 11 is a 1 and 11, but an 11 and a 1 can make a 12 or a 10. It's never going to make a 6. So I think factoring is kind of out. I'm going to have to go the quadratic formula, which happens a lot. No big deal. So the opposite of b is 12. Remember, negative 12 would be positive 12. Plus or minus the square root of b squared, negative 12 squared is 144. Use your calculator if you need to, but always make this positive. It's never, ever negative. Come on, it's a square. Anytime you square, you get a positive. Minus 4 times a is 2 times c is 22, all divided by twice a, which is 2 times 2, which is 4. So again, let's do that inside that the square root there, because that could be a little bit confusing, especially with some big numbers. It'll be 144 minus 4 times 2 times 22. And I get negative 32. So let me write that out here. So I get x equals 12 plus or minus square root of negative 32 all divided by 4. And I'm going to stop right there because remember, you cannot have negatives inside of a square root. That means there are no zeros, or that means there are no solutions. So if you just want to kind of understand what this means graphically, so at 1, 2, 3, 1, 2, 3, 4, up here at 3, 4 is the vertex, and the parabola must open up like this, where it actually has no zeros. There are no zeros whatsoever, because it's opening up and it's already above the graph. So be careful on graphs like that. Very interesting. All right, next up, let's find another one here. Let's do number 3. Okay, the function is going to be 4x squared minus 7x. And let's see here. Let's have this be minus 21. Okay, so first off, let's find that vertex. And remember that vertex is a point, so it's going to be a point. And to find this value, I need x. And let's see here. X is going to be this weird formula, negative b. Sorry, not weird, an easy formula, negative b over 2a. So negative, negative b, so that's negative, negative 7 is going to make that positive 7. Divided by twice a is going to be 8. 4 times 2 is 8. So I get 7 eighths. Kind of weird, but no big deal. And this is definitely where the calculator is going to come in handy, because I don't want to try to plug in 7 eighths by hand. I'd much rather let the calculator handle that 7 eighths for me. So I'm going to tell the calculator, let 7 eighths store as x. So right now the calculator thinks it's the decimal 0.875. That's 7 eighths. And then I'm just going to type in 4x squared minus 7x minus 21. I think it was 21, yeah. And I'm going to get, oh, what do you know, a weird decimal. And don't forget, I don't like decimals, so if you hit math, that very first option there, fraction, we'll take that answer and change it to a fraction. It's negative 385 over 16. Definitely didn't want to do that by hand. Negative 385 over 16. You know what? Sometimes you're going to get weird values. No, a vertex can be any point in the world, and that one's just a weird one. Don't let that, scare you. So now let's find these zeros, and I certainly don't want to factor that. I mean, that looks like it'd be a pretty tough one to factor. So I'm going to go right to using the quadratic formula. The opposite of b is a positive 7 plus or minus the square root of 49 minus 4 times a is 4 times c is negative 21. All divided by 2 times a. 2 times a is going to be 4, right? 2 times, oh, no, I take that back. It's going to be 8. I take that back. 2 times 4 is 8 on the bottom. I made a mistake there. All right, so once again, I'm going to let the calculator do that work inside there because that's a little bit complicated for me. 49 minus 4 times a negative 21. Really look up at that after you type it in. Make sure you typed it in right. And I get 385. So I get 7 plus or minus the square root of 385 divided by 8. Now, I don't know. Maybe 385 is a perfect square. It's worth to check it out real quick. It's worth to do the square root of 385 and see if maybe you get a nice perfect whole number. Of course, I don't. I get a decimal. So you kind of need to try to reduce that. So let's see if 385 is divisible, because maybe it has a perfect part in it. Like, is it divisible by, say, 64, which is a perfect number? And no. Is it divisible by 36? That's a perfect number. No. Is 385 divisible by, I don't know, 81? That's another perfect number. No. Let's start with something a little smaller, maybe. Maybe it's divisible by 4. That's a perfect number. No, close, but no. What? 380. Oh, I messed that up anyway. It's 385. Sorry, 385 divided by 81. No, still no. So let's try 385 divided by 4. No. So it's not looking like this is going to be factorable. So we could, what I would prefer to do, is let's take a look at this real quick. The square root of 385 is a 19.62. So real quick, the idea is this is 19.62. It's a decimal. So realistically, what happens here is we have some decimal one. They're still zeros. They're just decimals. They're just not perfect. So just be careful. Honestly, you can leave your answer like this. This is the exact answer that I'm looking for. If you want to get the approximate answer, which is great to do as well, you could do this. You would do 7 plus the square root of 385. Hit enter, and then you want to take that number and divide it by 8. So you get one of them is about 3.33, and then do 7 minus the square root of 385. And divide that by 8 as well. Always hit enter and then divide by 8. You get negative 1.58. So we got 3.33 and negative 1.58. So 3.33 and negative 1.58. So on the graph, you're going to have to, 1, 2, 3, 4. So 3.33 would be somewhere right around here. Negative 1, negative 2, negative 1.58 would be somewhere right around there. And those would be your two solutions. All right. So sometimes this doesn't work out perfect. Okay. So that's a real quick introduction on section 2.1. There's plenty more to come. We'll talk about in class, but that's a good start for you. Key thing that we're starting with right now is vertex and zeros. All right. Thanks, guys. Have a good one.